right, Unit 4, Lesson 6. Continue the explore. Remember, we're thinking about this flow chart here. Sorry, hang on a second. All right, so we want to make sure that they're always equal to 0, and all the factors have to be on one side. If they're not, you have to move all terms to one side, and the x term has to be positive and 0 alone on one side. So this one right here, we don't have all the terms on one side, and we certainly don't have 0 alone on one side. So it said something also about x needing to be positive, x squared. So we cannot move this one this way to get them all on the outside, so we need to move them all this way. So x squared, how do we move the 8x over? We subtract 8x from both sides. We add 15x. That'll make them 0 on that side. So that gets them all together. Once you're here, you're ready to factor. This is an easy guess and check because there's number in front. The a is 1. So x, and then there's a negative and a positive. That makes that double negative. Factors of 15 that add up to 8. Factors of 15. So 5 and 3, or 3 and 5, whichever. That gets us to there, and because this is an equation, we need to set each factor to equal to 0. And solve. So x can be 5 or 3 for this one. Right? That means that if you, let's put the 5 back in. X squared is going to substitute a 5. 8 times 5 minus 15. I'm just putting it back in for a quick check, okay, just to prove this is true. So that's 25. This is 40 minus 15. That will give you 25 equals 25. Okay, so 5 works, right? And you can do the same thing with 3 to show that that works. It's a quadratic equation. It has 2 answers, possible answers for x. All right, this one is already factored for me, but this is not equal to 0, so that's a problem. What do I do according to the flow chart for that one? It says, is my equation equal to 0? No, it's not. Do I have factors on one side? Yes, I do. It says I have to multiply them together, then move them all to one side. So that means I need to go ahead and FOIL this one. Okay, so it seems odd. Remember, the other ones we didn't do that to because they were already set to 0. What we need to do is factor this one, FOIL this one, combine like terms, and then move the 9 back this way. Sorry, I'm looking for my calculator. Hang on. I have a negative 12. Let me just double check that I did this first one right. Negative 21, right? Negative 9. Bring this over. Yeah, that's another key error. So let me fix that. All right, and then guess and check. Let's see, factors of 12 that are 4 apart would be a 2 and a 6, and the 6 would have to be larger. 2 would be over here. X equals a negative 2 and a positive 6, right? Because we set the factors to equal to 0. Sorry, we shouldn't shortcut that. Okay. All right, how about this one? Let me see. Right. Sorry, hang on, I gotta write down this one needs to be fixed. All right. There's a lot going on in this one here. So I need to move everything to one side to get 0 on one side, but which way am I going to move it? If I move this 7 this way, I'm going to be left with a negative 4x squared. I'm not allowed to have my x squared negative. So that means this has to go this way. So that means these have to go that way. So that makes all these equal to 0. And then over here is a 4x squared. That actually crosses out 2, and that's a negative 9. So I'm left with a 2-term polynomial to factor, perfect square minus a perfect square. So I can guess and check that one. That's 2x, that's the root of 4x squared. The root of 9 is 3, and then the signs are opposite. Set each factor to 0. Solve. Okay. Move. Isolate. Okay. All right, this next one, number 6, I need to move everything to this side. So negative 12x plus 9 equals 0. Add its opposite, so that'll go away. This looks like a tough one. Oh, no, wait. That's a perfect square, and that's a perfect square on each end. So actually, I can go right to here. 2x, 2x, 3, 3, and the signs would be opposite. Oops, no they wouldn't. Oh, no they wouldn't. Look, it's a 3-term, not a 2-term, so the signs aren't automatically opposite. It's a 3-term with a negative first and then a positive, so these have to be 2 negatives. I need to slow down. All right, so 2x minus 3 equals 0, and I don't need to do the same thing twice, so x equals 3/2. So even though it's a quadratic, you only have one solution. That's okay. It's the same thing twice. We don't write it twice. It just is the solution, okay? All right, this one looks weird, but it's a quadratic, which means we want to put everything on one side and get equal to one side. Now that's 2 terms, but it doesn't look like a perfect square minus a perfect square, but don't forget you're supposed to take out your GCF. Take out your GCF, what's left? That's still not a perfect square minus a perfect square, but it's still a quadratic because there was an x squared. So what you want to do is use 0 product rule and set both your products to equal to 0. Solve. So x equals 0 or 2. Okay, you can put them back in check, but they do. Greatest greatest common factor has to come out. Don't forget that we're doing that, okay? You don't want to be factoring things that are larger. I don't know about you, but I don't know how to factor or something with 3. So make sure you take out your GCF first. Find out what you have left. Then I need to factor that. Negative and a positive, so these are 2 negatives. Factors of 12 that add up to 7. Set my factors equal to 0. Set my factors equal to 0. X could equal 0. Positive 4. And 3. 3 x to the 3rd power means I had 3 answers, okay, unless there's a duplicate or something. That would be 3. Right, I'm gonna, how much more do we have here? Yeah, let me make a different one.